Hello everyone, I'm presenting 7th place solution at Kaggle COVID-19 detection competition. First of all, thanks to the host of this competition for organizing this amazing challenge. The task was to classify X-ray images based on COVID-19 abnormalities and detect opacities in the X-ray images. The metric was Pascal map. So here's our team. My name is Zaidan. I'm a 4th year computer science student at Nazarbayev University. Francero is a computer vision engineer at BTS Digital. Aslan is a master's student at Higher School of Economics, and Miras is a senior computer vision engineer researcher at Checklands AI. So here's the list of augmentations from Augmentations library. We use quite a few augmentations, and you can see 4 images and their augmented versions in this slide. And it's worth to note that the random crop was used only for classification models, and it helped to prevent overfitting a lot. For validation, we used multi-label stratified k-fold with 5 folds, stratified by the number of boxes and classes. For detection, we removed images without bounding boxes for the training set, and for validation, those were kept. For classification, we used EfficientNet B7, V2S, V2M, and V2L. Those were trained on 3 different folds with different image sizes. Auxiliary branches after 3 different blocks were added, which will be shown in the next slide. In total, we got 14 models, and their ensemble gave us 41.5 to 41.6% mean average precision. So here's the pipeline for classification. We have the original image, which is augmented, and binary masks are obtained from this. So this image is passed to the ConvNet, and each ConvNet is divided into 8 blocks before the pooling layer. After 6, 7th, and 8th layers, we add segmentation heads to segment regions inside bounding boxes. So we get binary masks, and those masks are compared against this ground truth mask, which is resized appropriately, and binary cross entropy is used for the loss. So all losses are added up, including these cross entropy loss from the probabilities from the main network. And we get the final loss from which we backpropagate. So here you can see auxiliary head outputs on the validation set. Those make a lot of sense, and we could actually use those as detection model by converting these segmentations into bounding boxes. But we decided to use more complicated models for detection. So here's the detection pipeline. We trained DetectRS and UniverseNet models using cosine annealing scheduler, SGD optimizer. We use multi-scale training using different image sizes given here. And for DetectRS, we added empirical attention. So here below you can see 7 different model results on the leaderboard. We also used pseudo-labeling to expand the dataset. Firstly, we trained UniverseNet 50. We trained binary classifier, which uses the classifier pipeline we mentioned, and we only keep images where binary classifier is confident that there is bounding box in the image. Out of those images, we filter out the bounding boxes using confidence of 0.4. We remove images without bounding boxes and add those labels, pseudo labels, to the training folds. And on these new training folds, we train UniverseNet 101. So here is the inference pipeline for the detection models. We use multi-scale testing with different scales, 640 and 800 for UniverseNet. And for DetectRS, we only use horizontal flip as TTA. So we get 7 models: DetectRS, UniverseNet 50, UniverseNet 101 on 5 folds. We use non-maximum suppression, non-maximum weighted for ensembling all these models with these weights, which are chosen from validation and leaderboard. So IUU threshold was 0.5. So thank you for your attention, and here's the link to the code.